Hey guys, welcome back to sediment transport simulation using HEC-RAS session. In this part, I'm going to learn you how can you use HEC-RAS for real case studies, define inputs, enter geometric data set, and run the model. And finally, I will learn all about the visualization process of a sediment simulation. Okay. First of all, we should create a geometric model for our case study. In this example, I want to load a predefined geometric model in this model in HEC-RAS. Let me upload. However, in the previous sections, I completely described about creating geometric models in HEC-RAS. In this window, you can see a straightforward case study river ridge with different cross sections. Let me plot some cross sections shape. Okay. You can see we have this channel shape for our case study. Okay. The main steps of creating sediment transport modeling in HEC-RAS contains or include flow time series. In the previous videos, I completely describe about unsteady and quasi-unsteady flow data set. In this case, I want to enter quasi-unsteady flow data set in order to model simulation. In the main window of a HEC-RAS model, you should click on View Edit Quasi-Unsteady Flow Data. And in this window, you should enter boundary condition types for downstream and upstream of your case study. As I mentioned before, in a quasi-unsteady and for upstream boundary condition, HEC-RAS allows you to only use flow series as boundary condition type. Therefore, I click these options, and in this window, you should enter the required data set about flow increment, computation increment, and flow duration. First of all, I click a fixed start time and enter the starting of our data set. For example, 01 August 1985, and our data started from 101, and that means that it start from time of 1. Okay, we should enter this important data set. Okay, I created this data set and I click all of them and select 3 columns and Control V. Press Control V. Unfortunately, in HEC-RAS, you can't right-click and choose a paste option, and you should select all columns and keep Control and V on your keyboard. Okay, when you click on plot, you can see this graph, which is related to quasi-unsteady flow time series. Okay, this is computational increment, and this is flow duration. Click on OK button. The next steps is to create or define boundary condition type at downstream. For downstream, we can select normal depths, stage series, and rating curve. In this example, I want to use a stage series because in this case, I want to model, I have a stage series data set. If you don't stage series or rating curve depth for your projects, you can use normal depths. In the previous videos or parts, I completely described about or discussed about these boundary condition types and their benefits and their drawbacks. Okay, I select a stage series, and like a flow series, you should click fix start time and enter the starting your data set. For example, 01 August 1985, and enter this time for starting. And these values must be similar to flow series in order to better simulation and avoiding errors in simulations. Okay, for a stage, we need to enter stage values and stage duration. Okay, for this example, I have stage values for different durations. Okay, click these columns and press Ctrl V. Okay, this is the stage series for this case study, and then press OK. And the final step, enter the temperature dataset, because some sediment transport modeling in HEC-RAS or functions in HEC-RAS requires temperature data in order to calculate fall velocity or other related temperature parameters. So I click set temperature, and in this window again I click or choose use fixed start time, and in there 1st August 1985 and the starting time. Okay, in this tab I click information about temperature and select these columns, and again Ctrl V, press Ctrl V. Okay, you can see this is the information about temperature. Because this project in US customer units, and therefore you should enter information in Fahrenheit unit. If you use metric system, you should enter temperature in degree unit. Okay, we defined all required quasi-unsteady datasets. Go to File menu and select quasi-unsteady flow. Q flow, and name it Q flow. Okay, we successfully created quasi-unsteady flow datasets. The second main steps is defining or entering a sediment-related dataset. Therefore, I click on Set Options, and in this window, you should enter required dataset. Let me to delete all of these. Okay, as I mentioned this is maximum depth and this is minimum elevation. This is suitable for unerodable beds or upstream of reservoirs, and max depth for natural rivers or the maximum allowable of erosion depths in HEC-RAS model. Okay, I provided some information about this reach, and again select max depths and min elevation columns and press Ctrl V. As you can see, some cross sections contain minimum elevation and some cross sections contain max depth. This means that some cross sections tend to sedimentation and they don't erode lower than these elevation values. But for some cross sections, you can see I use 10 feet, and this means that the maximum allowable of erosion simulation using HEC-RAS limited to 10 feet, and you can change these values in order to allow model to erode deeper depths. If you select profile plot, you can see like this profile, and this means that these areas can be eroded or deposited, but this cross section or this distance or reach only can deposit. They can't. The cross section located in this part, they can't erode because we enter minimum elevation information. Okay, for left and right station, or in order to use banks or excuse me, this information is related to movable bed limits, and you can use banks for movable bed. I click on these options, and the model automatically fill these columns. The next step is defining bed gradations information for each cross section or for each reaches. Okay, you can click on bed edit bed gradation, and in this window you should define your samples through the river reaches. If you have 2 samples, you should enter 2 samples informations. For example, in sample 1, these particles diameter varies between these values and these values. This is the finer percent, which is in accumulative unit. Okay, you can use this option, new bed gradation sample, in order to define or introduce new samples. For example, I want to introduce new sample, sample new, and in this page, in this column, you should enter the required or related information about bed gradation size and distribution. For example, I want to enter these values for these samples: 14, 60, 85, 95, 99, and finally you should enter 100%. Okay, I click on OK button, and in bed gradation you can select this sample new dataset. Previously I defined several samples, for example sample 1, 2, 3, 4, 5, and 6, and the information which exists in bed gradation sheet, and you can use this dataset for better training in HEC-RAS modeling. Okay, I select sample 1 for these cross sections and click and select sample 2 for this cross section, and so on. Okay, you can use again, for example, sample 1 for some cross section again. Okay, and do this selection for all cross section and for each cross section. Okay, let me save these files in file menu, select sediment, save sediment data. Okay, before going to boundary conditions, you should select transfer function, sorting method, and fall velocity method. As you can see, there are several important transport functions. But in this case study, in this example, I want to use Müller transport function. However, in order to define best transfer function in sediment transport simulation in rivers, you should calibrate this model for your case studies. In the previous parts, I completely described about how can you use observed dataset, or how can you able to calibrate this model for different transport functions. However, Meyer-Peter-Muller is one of the most important and most applied method in river engineering, and several case studies have shown that this method is very applied in natural rivers. For certain method, I want to use Thomas or Exner 5 method, and for fall velocity, again you can select different methods, but I want to use report 12 because this method is the basic fall velocity method for HEC-6 model, which is the previous version of HEC-RAS 6. Okay, there isn't any other settings. The next step is to define boundary conditions. For upstream boundary condition, especially for sediment dataset, you should enter one of these sediment boundary condition types: rating curve, sediment load series, equilibrium load, capacity ratio, and clear water or no sediment. In this case, I have a rating curve informations at the upstream of my river reach. Therefore, I select rating curve. But about these options, I completely described in previous presentation or videos. Okay, I click rating curve and then go to this window. In this window, you should enter the number of full load points. For example, if you have 10 full load points, you should enter 10 sets. If you have 100 sets, you should click and select these options. Therefore, it depends on your flow load point or your hydrometric station information. If you have more information, you can enter all available data sets. But in this example, I have only 5 flow load points. Okay, I go to the boundary condition sheet and select this information, right click, copy. And in this window again, you should select both rows and press Ctrl V button in your keyboard. Excuse me, I should select 5 sets. Okay, you can see there are information about flow in CFS and total load tons per day. And this is information about the materials of your loads in hydrometric station. If you don't have any information about this parameter, you should delete or let blanks all cells. Because in most case studies, especially in developing countries and data limited areas, we don't have other information about loads, and only we have the information about the values of total load. We don't have about the distribution of grain size in each load. Therefore, you can let these columns left. However, in this case study, I have information about the percent of grain size of each bed load. Okay, again, when you press plot, you can see the variation between flow and total load. And I press OK button. And finally, save sediment data. Okay, we have done all most important steps, and the final step is running the model and visualizing the output of the model. Okay, for running the model, you should click perform a quasi-unsteady flow simulation icon in the main window of HEC-RAS. Okay, you should select the required information, for example, geometry, quasi-anesthetic flow, and sediment data. And you can run the model for the period which is equal to flow series or a quasi-anesthetic flow data set. For example, if you have 4 years information for flow series, you can run the model for 5 years, not only for 10 years or for larger or more time steps. This information limits your, for example, 1 of September 1988. This is the final runtime which is allowed in using HEC-RAS. Okay. Therefore, I want, in order to decrease the time of this video, I want to run this model for only 1 year, not for 2 or more years, because the running model will be increased. Before running the model, you should go to the option menu and click sediment output options. Okay, these icons or these options completely clear, and in the previous parts I completely described the meaning of each setting. Therefore, I click the output level 4, mass or volume, I select volume, and the output increment I want to use computation increment, or you can use hours or days or flow durations. And for cross-section bed change output, I want to use number 1, because I want to run model. I want to show the output result after 1 computation increment. This lead to this lead to more volume of model output, but in the visualization process, it helps us to create better animations about the variation of bed change and other sediment transport parameters. Okay, in the select customize variable, you can select other informations. For example, I want to show water surface, invert change, fall velocity, and other one-day related information. For example, mass cumulative, lateral structure, volume in cumulative, and other information if you want to show in your output. Okay, press OK, and then go to again options, select sediment computation options and tolerance. And in this window, you can change this computational options or use this default value. I click default values. Okay. And you can click on show X weighted and change these weighting parameters. In the previous video, I completely describe and explain about these options. For example, if you use different weighting for upstream current and downstream cross section, you can see the effect of XS weighting factors. You can run the model for the default value, and if you see the outputs contains different oscillation and noises in output, you can change some factors in order to decrease the oscillation in the output of modeling. Therefore, I click these values for upstream. This is for the main cross section or the current cross section, and this is for downstream. However, you can change these values and these values to improve your model running. Okay, I click OK, and you can run the model by pressing compute button. Excuse me for delay. I click on compute, and the model starts to running, and it depends on the output level, it depends on increment, it depends on the number of your cross sections, and it depends several factors. I mean, the running model depends several factors, and you should be wait to finish the running model. Okay, in order to increase the time of this video, I click on pause, and after the running is finished, I will show you the outputs of model. Okay, the running has finished, and I click close. In order to visualize the sediment-related output, you should go to View menu, and you can click sediment output version 6 or legacy sediment output, which is related to other version. I personally believe that the previously version of HEC-RAS contained better graphical and tabular outputs to present sediment simulation results. Therefore, I click legacy sediment output and click sediment output HEC-RAS version 5. Okay, this is one of the most important windows or outputs of HEC-RAS, which can you can create different time series, profile, or cross-sectional information. And in this part, you can see the output of model simulations parameter, which is related to the level of, output level of HEC-RAS, which is located in the options menu. For example, I want to click invert change, and you can click one of these cross sections, and this is the time series of variation of invert change for this cross section. As you can see, in sometimes we have some positive values, and after sometimes the sedimentation process reach to constant value. For example, if you want to show the cross-sectional information, you just click on X's and click one of these cross sections and one of these time values. This is related to first of our simulation. And if you want to show more three or more profiles, you should keep control on your keyboard and select some profile or your time steps. As you can see, in sometimes we have the position in our cross section. Okay, I go down while keeping control button in my keyboard, and then select the other profile, and you can click on final profile. Okay, you can see the variation of your cross sections. Let me move. Okay, you can click different cross sections, and you don't need to hold control on your keyboard. In this step, you can click different cross section, and you can see the variation of your cross section bed in different profiles or time series. Excuse me, in different time and in different cross sections. For profile, you can select, for example, invert elevation, and you can hold control. Let me show control. I hold control on my keyboard and click different profile. As you can see, the variation of or the movement of sediment through the river. This is the longitudinal profile. This is upstream of my reach, and this is my downstream. As you can see, in the middle of this river, the model tends to sedimentation because we define the minimum elevation for this area, and the lower part tends to erosion because we insert the max depth information for downstream parts. Okay, and you can create different bed profile at different times. Okay, this is the color of each profile. Inverted elevation, and you can plot flood number. This is flood number, this is flow, this is invert elevation, invert max, invert mean, and you can show, for example, volume. This is related for each grain size. This is one of the most important outputs of HEC-RAS, and you can see the variation of each particles through the time in each cross sections. Okay. This is time series, and you can see the variation of each cross sections, the variation of each sediment related or flow related parameter in each cross section at different times. Also, you can let me click profile, and you can animate this variation of this profile. However, in this window, the animation is not very good, and in the next step I will show the better options to create animations in HEC-RAS. Okay, this is one of the most useful parts of HEC-RAS, and this is table, and you can select information about selected variable. Okay. As I mentioned, the other options to visualize the model is related to options which is existed in version of 4 in HEC-RAS, but in the current version we don't see these options. Okay, this is another options to create output which is very similar to sediment outputs in HEC-RAS 5. In this section you can click on animate, and you can see the variation of bed elevations in different sections. Okay. Okay, you can see the final bed profile. However, in this window, you can select different profiles, different times, and you can see which parts tends to sedimentation and which parts tend to erosion and which parts is stable. As you can see, this part is stable, this part is deposition area, and this is the erosion or erosive ridge. For example, you can create different variables like in version 5. This is the invert change, one of the most important parameters in river engineering studies, and you can see the variation of bed change through the river in different location. Okay, you can press on stop. In addition, you can create a schematic plot for distribution of sediment or variation of invert change or other variables in schematic plots. As you can see, I click invert change, and by using this option you can see the spatial variation of invert change through the river. You can see the blue color related to the position and green color, red colors related to erosion. Excuse me, the red color related to deposition and blue colors related to erosion. And green, the red colors state that this area have the potential of deposition, and the blue colors means that this area tends to erosion. Okay, in this table you can see the outputs at each time or profile. You can use different profiles, and you can see the invert change through the river at different times. Okay. Again, you can select sediment time series plot. Okay. This option is available in all variant, and you can select each cross sections and then select variable, for example, invert change. Let me uncheck invert, and you can see the variation of bed invert through the time. However, you can show the volume bed change of all particles, and this shows the volume of sediment through or passing in these cross sections. Volume in cumulative for all particles passing this cross section. As you can see, after this time, the models result a constant sediment volume at these cross sections, which is passing this cross section. And other information. If you select different levels, you can create or visualize other related parameters. Okay, and the final visualization method is expect change plot, and this is very similar to previous options. And if you want to work each of them, there is no difference. And in this options, you can select each cross sections and then go to profile, and there is no need to hold control on your keyboard. This is just click selected time. Okay, and you can see different cross section variations through the time. And also for these cross sections, you can use animations to see better variation of your cross sections through the time. Okay, there isn't any options. Before finishing this part, I should state some important tips. However, in the previous parts, especially in this PDF file, I completely described the importance of each settings or each options. But again, I want to state this setting. For example, you can go to sediment data and go options and select bed change options. And you can use several options for better simulation of or better alteration of sediment in each cross section. The default version is this option, but I select veneer for both channel and overbank, and also you can change the area method to see the improvement or unimprovement of your outputs. And you can select transport methods. This is one of the most important reasons of model instability, because sometimes if you select continuity routing method, the model create noisy or oscillation results in the output. But in this case, you can use one of these options. But I personally believe that selecting limit to water velocity is the better choice in order to increase the erosion or depositions through the river, and this is very close to the natural process in rivers. And also you can change sediment junction split method. Potential weighted is very good, and pull pass-through method, the upstream capacity is the default choice. However, these options for 2D, and you don't need to select or change these options. Okay, this is, I think this description required, and you should consider all of these options and all statement I said, or I said in the previous parts, especially in this file. And after completely reviewing all these steps and videos, you can easily run sediment transport for your case study. I hope you have enjoyed, and if you have any question about this modeling process, you can contact me. Have a good time. Bye-bye.